child rides a pony on a circular track whose radius is 5.25 meters. Find the distance traveled and displacement after the child has gone halfway around the track. Does this distance travel increase, decrease, or stay the same when the child completes one circuit of the track? Does the displacement increase, decrease, or stay the same when the child completes one circuit of the track? Find the distance and displacement after complete circuit of the track. So let's draw ourselves the track. And we will say that the child starts off, let's say, on the due west point, and then travels, let's say, the due east point. We'll take due west. And so we will take our coordinate frame to be that the west is x equals 0, and then the child travels halfway around the track. We want to find the distance travel and displacement after the child has gone halfway around the track. So the distance would be 1/2 the circumference of the circle. And we know the circumference of a circle is 2 pi times the radius. So the distance traveled would be 5.25 pi meters. The displacement is the difference between the starting and ending location, and this place must be twice the radius. Must be the diameter of the circle. So delta x is then 2r minus 0, or 10.5 meters. For comparison, 5.25 pi meters is the same as 16.5 meters. So that's about right. And that was, of course, part A. Part B is, does the distance increase, decrease, or stay the same when the child keeps walking? So the child keeps going back, right? And they go all the way here, and now they have traveled one full circumference, which is clearly twice as far as for part A. And then for part C, they ask the same thing about the displacement, but now the child is back to where they started, so the displacement is 0. And accidentally, we've sort of answered D along the way, where we get now the new distance after one circuit is twice the distance for halfway, or 10.5 pi meters, and delta x is 0 minus 0, or 0 meters. Key difference between displacement and distance.